All right, so here we are on September 24th, and we have 4th hours data up on the smart board. So here's the data we can see for the first 3 groups. And then we have the next 4 stations, some different data here to copy down if you need to copy it down. If you've already copied it down, good. And then there's station 8, and there's our questions that we were just discussing in our groups that we're going to share out with the class now. And so we're going to start off with station 1, which was the wood splint. And so sharing with us about the wood splint is going to be Terrence. Terrence, this wood splint station, first of all, did your group think that there were any really weird measurements there? No? Okay, so all the data seems like it's pretty close together. What do you guys think is the general trend? What happened at the wood splint according to the data? It went down, okay? So it went down a little bit. I think we all agree that it went down a little bit here. So what did you guys say in your discussion? Did you think that that made sense that the mass would go down a little bit? Okay, you guys did think that. Why? What was that? Okay, table 3. So why do you think that that makes sense that the mass goes down? What does that mean? First of all, if the mass goes down, what happened? We lost particles. So does that make sense with burning a wood splint that we would lose particles? Okay, so where do you think the particles went? Into the air. Okay, so I'm going to go ahead and write that down then. So lost mass, and according to what we know about mass, we should know that that means we lost particles into air is what you're saying. All right. Okay, cool. Thank you. All right, let's move to station 2 where we had melting ice. Talking about melting ice is going to be Jacob. Do you mind telling us what your group said about melting ice? First of all, is there any data there that seems like it's off? Number 5 looked off. Anybody disagree? Think that that number should be included in our data? Okay. Any ideas for what they might have done? Spilled some water out of there? Okay, good. So the rest of the data, what are you kind of seeing there for a general trend? What do you think is? Okay, so we had some that there were no change. We had some that looks like it gained a little mass. We have one that looks like it lost some mass. Um, and so you got to understand when we make these measurements to have it be off by a couple tenths, there's going to be some error with our measurements. And you guys know these balances are very sensitive, so even just moving around them, bumping the table, even moving air around them can make the numbers change. So it's okay to see some slight differences. Okay, so overall, if we account for that, what do you think is happening here? Mostly staying the same then. Does anybody disagree? So if it's mostly staying the same, what does that mean about the number of particles? No particles were gained or lost. Okay, thank you. Let's talk about steel wool pull apart. And this is going to be Brianna. So Brianna, steel wool pull apart. First of all, does it look like there's any data that doesn't belong? You thought 5 should not belong? Anybody disagree with that? Nobody disagrees with that? I mean, looking at these numbers, so no change, no change, no change. No change. Exactly the same measurement. It's not easy to do, especially at this station. And here, very small change. Number 7 looks like a bigger difference than number 5, right? Because that's negative 0.6. Okay? I would say personally, I would say these are all right. They're still just small changes. It's not like they went up to like 15 or 50 or 100 or something like that. It's still small changes. Okay. So what do you guys think the general trend was? What's it say that happened at that station? Stayed the same. And does that make sense to you? If we take steel wool and pull apart, does it seem like the same number of particles would be um, at the beginning as at the end? So does that make sense for station 3? Steel wool pull apart stayed the same. Okay. Can anybody think of a reason why we might have had these negative numbers? Jake? Yeah, I was saying we should probably keep it. I think we should keep both. They're just small changes. Okay, there's going to be some built-in error. I think ones that should be kicked out would be if you've got very small changes like that, and then all of a sudden somebody had like 25 grams gained or lost or something. All right. But can anybody explain, if you think about it, anybody think why we might have gotten negative 0.6 or negative 0.49? Meaning that we lost particles somewhere? Michelle? Okay. Very good. Doesn't that make sense? I mean, I know when I was helping groups over there and I was pulling apart that steel wool, I had it on my fingers afterwards. So I think it would actually make sense that we should lose some particles there. But we'll go with stayed the same because ideally I think that makes sense. All right. So then what we did was we took the steel wool and we burned it. All right. So burning the steel wool, Eddie, can you tell me what your group said about burning the steel wool? Was there any data that you guys wanted to kick out of there, first of all? What's that? 5. So you wanted to kick this one out? Okay. Does anybody disagree with that? You think we should keep 5? Okay. Do you guys think there's any other ones we should have gotten rid of? What, you're talking about this? How can you gain by burning something? How can you gain mass? Yeah, how would it gain particles? How, so if we burn, so there's a good question to consider. That's a good question to consider. If we burn something, how could it gain particles? Just think about that. We've got a chance. All right. Well, so this was similar to station 1, right? And okay, think about that. Think about it. We'll talk about that more later. Okay, we'll think about that more later. All right, so just goodness, I hate to break it up because you guys are having a good discussion, a really good discussion. Um, so what did you guys think the general trend was, Group 7? What do you guys think? Lost a little bit, and that makes sense to you? So I'm going to write lost mass. Does anybody disagree with lost mass? Does that make sense with what you're thinking at lost mass? Okay. All right, so we lost some particles, and I would imagine if you're talking about what you said with station 1, you're probably saying that particles left into the air. Is that what you're saying? Is that why? Okay. Let's go on to sugar dissolving. So I've got AJ. AJ, did you guys say that there's any data for station 5 that we might want to get rid of? So station 5 here, you think there's any data we should get rid of there? Seems like it was increasing. Okay. Do you guys agree that it's increasing? Increasing, so gaining mass. Does anybody think there's data we should kick out of there? Did any other group say we should kick some data out? The negatives, those seem a little out of place. I mean, half the groups had negatives. So should we really kick them out? 1, 2, and 7 had negatives. You guys think that group 5's data should stay at gain 61.84 grams? What do you guys think might have happened there? Might not have zeroed out the balance to account for the container. What else could have happened? What we see at these stations, 5, 6, 7, and 8, when we start combining things, when people are combining or comparing their final mass to their initial mass, sometimes they forget that their initial mass is actually the two ingredients masses combined. So sometimes that makes a big difference. So they may have only been comparing the sugar and water combined, that mass, to maybe just the water. Okay, that's a possibility. So, what did I call it? AJ, so you guys think it gained mass. Does everybody else agree that it should gain mass? When we add sugar to water and dissolve it, it should gain mass? Anybody disagree with that statement? Nobody disagrees with that? So if we take the particles that are in sugar, and we've got that mass, so this number of particles, and then we take the particles in water, and that's that mass, and then we add them together, we should have more particles. So where did the more particles come from? Water and sugar, I know, but we accounted for the mass of the sugar, and we accounted for the mass of the water. So if we have a gain, where did the new particles come from? From the air. So when we dissolve sugar, air particles come in? Anybody disagree with that or no? You're shaking your head, Michelle. Okay, fair enough. All right, so we'll hang on to that for a little bit. So far, our consensus is that we should gain mass. We should be gaining particles from somewhere. All right, we'll try to do one more station 4 today. Let's talk about the baking soda and vinegar. Sharing with us about baking soda and vinegar is going to be Kiana. So, Kiana, what did you guys say about the baking soda and vinegar? First of all, are there any numbers that you think are wrong? Did you guys think there was some data there that maybe was inaccurate? So for this station 6, baking soda and vinegar, do you think there's any of that data maybe that's inaccurate? Which one do you think? Number 6? Well, 6, we didn't have data. So yeah, we're not going to use that. 7, no change. Anybody disagree with those? So let's take a look at what this really means. Okay, take a look at what this really means. Station 1 says, lab table 1, they said it gained 2.51 grams. So it gained some particles, quite a few particles actually. Station 2 said it lost a ton. Do you think maybe that's a mistake? I mean, 30 grams is a huge difference. Okay. Table 3 had lost 29.51. That many particles. So when we combine baking soda and vinegar, it could have lost 29.51 grams. Jake, were you raising your hand, Jacob, to say something? Okay. So this, I mean, how could you gain 170 grams? First of all, with the baking soda and vinegar, what happened? You think it should lose? Why? Tons of bubbles. Where'd those bubbles go? Into the air. So does it make sense we're going to lose mass on this station? I think it does. I think we should lose some mass. Now, are we going to lose 30 grams? Maybe. I don't know. Maybe we'll keep those then. Lose 0.73 grams? Maybe. Gain 2.51 grams? Does that make sense? Okay, so that doesn't make sense. All right, so we're going to say that it lost mass on this one. You guys gave a pretty good explanation for that too. All right. Let's go ahead and stop there for today, and then we'll do the last two stations tomorrow before we start modeling these things. All right.